Everybody, can you hear me? Can you see my screen?
Yeah.
Okay, so today we continue learn chapter 10. Last time we have not finished section 1, so we continue section 1. So the first problem we see here, that's a clock at the right shows the time of 3:30, right? So this clock now shows 3:30. So the hours clock, hours hand point to between middle of 3 and 4, right? And the minutes hand point to 6. So this means 3:30. So now they ask you, what is the measure of the smaller angle between the hour and minute hands of a clock at 5 p.m.? Everybody, can you try to answer this question and send me your answer in private chat? Okay. Okay, very good. Joyce is correct. Eric is correct. So that means if I draw here, that will be like this. The hours hand point to 5, right? The minute hand point to 12. So then they ask you, what is this angle? They ask you, what is this angle? Because this one is a smaller angle. Otherwise, you need to calculate this one larger angle. So this one, because that's 30 degree. From 5 to 6, the hour 5 to 6, that's 30 degrees. Therefore, this one is 150 degree. Because this one's a straight angle, that's 180. So you use 180 degree minus 30 degree, because this one is 30 degree. Then you got a 150 degree. Okay, this a little bit easy. So Joyce correct, Eric correct, Rebecca is correct. Now Justin, you need to double check your answer. So then next one is a little bit challenge. Then this one, they ask you, what is the measure of the smaller angle between the hour and minute hands of a clock at 5:24 p.m. So I can help you draw. So 5:24, that's this is the hours hand, right? And minute hand point to, this is here, that will be 20. 24, that will be something here, right? So then they ask you, what is this angle? They ask you, what is this angle? This one. Okay. Now let's see. Yeah, Joyce got correct. Who else? So Rebecca is also correct. So first, let's do this way. First, can you calculate the hours hand? How many degree One way we can do this. I think one way we can do this. You can calculate hours hand pass how many degree from 12. Then you calculate minute hand how many degree past 12. Then you use hours hand, that angle minus minutes hand, then you get this angle, right? So, for and let's say for hours hand, the path 24 minutes, then this one divided by 6 minutes, this convert to hours, right? When hours hand, they move 1 hour, past 1 hour, they pass 30 degree. 30 degree. Because if hours hand move from from 1 clock, then go to 12 o'clock. That's 12 hours, right? 1 hour moved, if hours hand move 12 hours, then hours hand will move 360 degrees. That will move exactly 1 circle, 1 full circle. Then each hours hand will move the 30 degree. So by this way, we can simplify this. That means we get 12. So that means hours hand past the 5 o'clock. Past the 5 o'clock, that's 12 degree. Then you can say for the minutes hand, if they point to this minute hand, if it point exact to 5 o'clock, that will be, minute hand for each minute hand, that's in 6 minutes they will move 360 degrees. That will move minute hand will move the full circle. So therefore, for each minute, minute hand will move 6 degrees, right? 360 divided by 60. So that means minute hand will move 6 degrees for each minute. Now, the minute hand point to 24 minutes. So that's 1 minute away from 5 o'clock. This 5 o'clock sign, okay? So that means this angle, that will be 6 degrees. And this angle for the hours hand formed with this sign. If I draw this one from here, no. Okay. If I draw this one, but here it's very small, okay, maybe it's not easy to see. What I want to say, 5 o'clock form with this blue color line segment, that's 12 degree. And this minute hand form an angle with this blue line segment, that's 6 degree. Therefore, the hours hand and minutes hand, they will form an angle that will be 12 plus 6. That will equals 18 degree. 12 plus 6 equals 18 degree. Okay. Then another way, as I said, you can calculate the minute hand. When they move to here, the angle they formed with this 12 clock, that will equals 24 times 6. That's give you 120 44 degree. So that means this angle will equals 144 degree. Now the hour's hand, this hour's hand, they will form angle, you know, that's 5 o'clock. 5 o'clock, that's 5, because each hour, that's 30 degree. That's 150 degree, right? Then you plus this, because you still have 24 minutes. 24 minutes, that give you 12 degree. So this one, this one will equals 162 degree, right? Then you use 162 minus 144, that will give you the angle between hour's hand and minute's hand. That will be equals 18 degree. That's we got the same answer, right? So two ways to calculate, right? One way, you all compare with 5 o'clock, this blue line. The hour's hand will form angle with this blue line, that's 12 o'clock, 12 degree. Then the minute's hand will form an angle with this blue line, that's 6 degree. So you add it together, you got 18 degree. Another way, you just calculate the minute hand form angle with this 12 o'clock, that's 144 degree, because that's equals 24 times 6 equals 144 degree. Then the hour's hand will form angle with this 12 o'clock, that equals 5 times 30, then plus this 12. So you got a 162 degree. 162 minus 144, you got 18 degree. Okay, so this is number 2. Now let's see number 3. Here they ask you what is x. Okay, they give you the all other angles here. Then they ask you what is x. Okay, everybody, can you send me answer? Now, let's see. Everybody got a 73? Okay, now let me ask. Brian, can you explain how you got a 73?
So I know that like the full circle is like 360.
Okay.
So I added like the 3 sets together and did 360 minus 287 and got 73.
Okay. Now let me. Yes, that's way is correct, but I don't know if you got this number is correct. So that's x plus 64 plus 80 plus 143. This should equal 360, right? So now if we add these two together, we get this one is 144. So then we add this together, we got 287. Okay, so then we minus from 360 minus 287. So that's 3. Yeah, 73. Yes, correct. Very good. 73. 144, 73. Oh, yes, 73. Correct. Very good. This is correct. So Joyce correct, Rebecca is correct, Eric is correct, Brian is correct. Very good. So now let's go to next problem. Number 4. So this one, they ask you, what is the measure of AOB? AOB is straight line. What is the measure of angle AOB? Okay, Eric's correct, Joyce correct. So this one called a straight angle, okay? I already used this one a couple of times. They tell you AOB, that's a straight line. Then they ask you angle AOB. They ask you how big is this angle? Because AOB is a straight line, then this form a straight angle at O. This angle will equals 180 degree, okay? 180 degree. So Justin also correct, Brian also correct, 180 degree. Now let's see number 5. Say in this picture, they give you RS and PQ intercept at point O, okay? And angle SOP, this one is 37 degree. They give you this one, SOP, this one equals 37 degree. Then they ask you, what is the measure of POR? What is this angle? Okay. Okay, Justin is correct. Eric is correct. Brian is correct. So this one should equals 143. Why? Because ROX, that's a straight line. So then this angle ROS should equals 180 degree. Then that means angle POR will equals 180 degree minus angle SOP. Then this one equals 180 degree minus 37 degree. Then we get 143 degree. Okay? That's correct. Very good. Now let's go to number 6. This one, they tell you the line WX and YZ intercept at point P. And they give you YPX, this one is 61 degree. Then they ask you, what is WPZ? WPZ, what is this angle? Okay, yeah, correct. Brian, Justin, Joyce. This one is very easy. Just equals 61 degree. Because these two angles called vertical angle. Okay, vertical angle. Vertical angle, that means if you have these two lines intercept at a point, then these two angles against each other. Okay, just on the both sides of this point P. Then this called a vertical angle. Vertical angles are all same. They should equal 61 degree because this one's 61 degree. Okay, this one's very easy. Now let's go to number 7. See line WX and YZ intercept at point P. Explain why we must always have WPZ. WPZ equals YPX. Then here they ask you why this one always equals this. Okay? Why this one? You know, we know that they're equal, right? But how you can prove or how you can explain why they are always equal? Let me ask Eric. Can you explain why these two angles always equal? Eric?
Well, I guess I know, but I don't really know how to explain because I guess they intersect at point B, and they're just both like the same.
Mm-hmm.
So yeah.
You can use a straight angle to explain this. Okay. So
they're the same and stuff. So yeah.
let me show you how to do this. Okay. You know, here WPX is a straight line, right? This one is a straight line, right? Then we have angle WPX equals 180 degree, right? Because WPX is a straight line, therefore we have angle WPX equals 180 degree. That's a straight line, right? They form a straight angle. So this one equals angle WPY plus angle YPX, right? So that's equals this angle plus this angle, right? Then YPZ, okay? Because YPZ is also a straight angle, is also a straight line. This one also a straight line, right? Because they tell us this is the two lines, right? WX and YZ are two lines. Their intercept at P. So therefore, YPZ is also a straight line. Then we can get an angle YPZ. This also equals 180 degree, right? This 180 degree, that equals angle WPY plus angle WPZ, right? Then you compare this and this. Say 180 degree. This one equals this. Therefore, this one always equals this. The angle YPX should always equals WPZ, right? Say this angle plus this angle equals 180 degree. This one plus this also equals 180 degree. Therefore, these two angles should always equal. Otherwise, that's not possible. So the most important thing is a straight angle equals 180 degree. Then this 180 degree, we can use this angle plus the same angle, this one, WPY. We can also use this angle plus this WPY. Therefore, these two angles have to be same. Otherwise, they cannot happen. So this actually just to show you how to write a proof, okay? Now, let's go to number 8. Now let's say, Joyce, can you help me read this problem?
The measure of one angle formed by two intersecting lines is 3 times the measure of another angle formed by the lines. In this problem, we find the measures of the angles formed by the lines.
Okay, so to solve math problems, especially for geometry problems, draw the graph that's most important. So first, here you need to draw, say, the two lines, the measure of one angle formed by two intersecting lines. Now let's draw these two intersecting lines here. Suppose this line M, this line L. Maybe you can, does not matter what letter you use. So this said is 3 times the measure of another angle formed by the line. So that means this angle, suppose this angle equals x, they tell you this angle will equal 3x, right? Say the measure of one angle formed by two intersecting lines is 3 times the measure of another angle formed by the lines. In this problem, we found the measure of the angle formed by the line. Then A, they ask you to draw a diagram for the problem. That's what I draw here. Then let x be measure of the smaller angle. I use this x to represent a smaller angle. Then find the measure of each angle in the diagram in the term of x. Write this measures in your diagram. You can know this angle also equals x. This also will equals 3x, right? Then they ask you to find the measure of all angles formed by the line. Then you can say 3x plus x will equals 180 degrees because this is a straight line. Then they will form a straight angle. So then you solve this equation. This one, 4x equals 180 degrees. So that means x equals 45 degrees. Okay, correct. Then this 3x, this bigger angle will equals 135 degrees. This one's 45 degrees. Okay, so Eric is correct, Joyce is correct. Okay, so the smaller angle, that's 45 degrees. The larger angle, that's 135 degrees. Okay, so we finished this first section. Now let's go to second section. This section we'll learn the parallel lines. Parallel lines is very important. They play a very important role in geometry. When you have parallel lines, then you have usually, if in two triangles you have one pair of sides, they parallel to each other, then you get these two triangles we call similar. So that means their shape is same, but their size probably is different. But that's not only for the application of straight line, the parallel lines. When you have parallel lines, then you can also use this one to solve a lot of other problems. Let's say parallel lines, that means they will never intercept each other. Okay, the distance between these two lines are always same. Okay, you can say the shape like this. Now let's say how we can use parallel line solve a lot of other problems. Let's say this problem 9. They ask you to draw a pair of parallel lines like this shown below. Then draw a line that cross both of the parallel line. Then with a protractor, measure all the angles formed between your line and both of the parallel lines. Write the angle measures in the angles you form. Try it again at a different pair of the parallel lines. Do you notice anything interesting? So then you can draw any way what you want. Here you can say we'll form 8 angles here. Suppose I use this one. This angle is 1, this number 2, this one's number 3, number 4. Then here suppose number 5, number 6, number 7, and number 8. Okay, so you got these 8 angles. You know, last time we already write angle 1 will equals angle 3, because these 2 angles we already proved they are always same, always congruent, because they are vertical angles. And this angle also equals angle 5. Angle 1 and angle 5 called corresponding angles. This angle and angle 1 and angle 5 always congruent. Angle 5 also equals angle 7. Okay, because angle 5 and angle 7 also they are vertical angles. Okay, we have this. Then we also have another equation that equality that's angle 2 equals angle 4 and also equals angle 6, also equals angle 8. Angle 2 equals angle 4 equals angle 6 equals angle 8, right? And we also have angle 1 plus angle 2 equals 180 degree. You can see here angle 1 and angle 2, they will form a straight line. This is called straight angle. Angle 1 plus angle 2 equals 180 degree. This one definitely also equals angle 3 plus angle 4. Also equals angle 1 plus angle 4. Okay, but I also have a lot of other equalities here. I don't need to write that. I think you can get that if you want. Now let's go to number 10. See, this one, they give you 2 parallel lines, M and N. Then we have another line intersect with these 2 parallel lines. Then they form 8 angles. Then they give you this angle equals 35 degree. Give you this one 35 degree. Then they ask you to write all the measure of other side, A, B, C, X, Y, W, Z. So can you write down what is measure of A, B, C, X, Y, W, Z? Okay, now let's see. Here you need to give me how many? Totally 7 angles. You need to give me 7 answers. So first, let's do this. Everybody give me what is angle A? What is A equals? Joyce, correct. Who else? Angle A, that's equals 180 minus 35 degree. That's equals 145 degree. Okay, this is A. Then everybody give me B. What is B equals? B, yeah, Rebecca correct, Joyce correct. B, that's a vertical angle of 35 degree. This also should equal 35 degree. Okay, then now let's see C. What is measure of C? Yeah, C equals A, that's 145 degree. Okay, then now let's find what is W. W, that's equals A. Yeah, Rebecca, that's correct, 145 degree. Then what is X? X, 35 degree. Yeah, Joyce correct. Y, that's equals X. that's also equals 35 degrees. Then z equals w, that's equals 145 degrees. Okay, very good. Yeah, this is the answer. Okay, so now 11. 11, they tell you a chicken starts at a point X. Start from this point on the one side of the road. It starts walking across the road along a path, makes a 22 degree with the side of the road as shown. Before making it to the other side, the chicken makes a sharp turn at point Y, then and starts along a new path, which makes a 71 degree angle with the old path. That means this angle equals 71 degree. If the opposite side of the road are parallel, that means this one parallel with this, then they ask you what is the measure of the accurate angle or that path of the chicken makes with the far side of the road at point Z. Then they ask you what is this angle equals? What is this one? Okay, Eric is correct, Joyce is correct. Everybody think how to do this one. Rebecca is correct. So to do this, what I see here, I will draw a parallel line path through the point Y. Then this line we call that additional line. In geometry, to solve problem, general trick, that's draw additional line. I draw this line, make this line parallel with this line. Because these two lines parallel to each other, after I draw this line parallel to one of them, definitely will parallel with another one. Then this angle will equal this one. That means this angle will equals 22 degrees. Because these two angles are called alternative interior angles. Alternative, they called alternative interior angles. Interior angles. In a different side, but all is inside of these two parallel lines. So they're called alternative interior angles. So this 22, this also 22 degree. And this angle will equals 71 degree minus 22 degree. That should equals 49 degree, right? But this angle will equal this angle because these two angles also alternative interior angles. So that means this angle should equals 49 degree. Okay, so the answer for this one, that's 49 degree. Okay, Eric, Joyce, Rebecca all got this one correct. Very good. So now let's say, yeah, actually we yeah, we already finished this section. Now let's go next section. Next section, that's angles in polygon. Okay, so to learn this, first you need to know what is a polygon. Polygon, say that's a simple closed figure consisting entirely of line segments. So you can say this three, that's a polygon. This one has 5 sides. We also call this one's pentagon. Okay, 5 sides, pentagon. This one has 4 sides. We call this one it's quadrilateral. Okay, 4 sides. This one have 1, 2, 3, 4, 5, 6. 6 sides. We call it hexagon. Okay, you can see each side it's a line segment. Okay, so and also they form a closed figure. Okay, so then this kind of figure we call polygon. But then these three are not polygon because this one is not closed, right? Even this each side is a line segment, but they did not close. Here is open, so this one is not polygon. And this one is closed, but this side is curved. It's not line segment, so this one is not a polygon. And this one, each side is a line segment, but they form the 2 closed sides, 2 closed range. So this one also we don't consider that's a polygon, because we define polygon as a simple closed figure, consists entirely of line segment. Here that's a complicated. You got 2 closed region. So this one also not a polygon. So then we concern what is angles in a polygon. So you can see here we have this points we called vertices. Okay, so this pentagon has 5 vertices. We call this one vertexes. Vertex. Each one called a vertex. Then here we have 5 vertexes. And this connection between any 2 vertices we call the side. So for the pentagon, they have 5 sides. Okay, 5 sides. Then if you connect the like here A and now connect here, that's A and another point, another vertices. If you connect A and E, AE we call the diagonal. That's not side, that's called diagonal. Okay, then we also can say here we'll form 5. This one that's a hexagon. 1, 2, 3, 4, 5, 6. 6 sides. We'll form 6 interior angles, right? This one we called interior angles because that's inside of this hexagon. Then for this pentagon, you also will form 5 interior angles. Okay? So the one question is, what is the sum of these interior angles? You know, let's start from the triangle. If it's a triangle, we already know this one. This angle plus this angle plus this one. We already know this one equals what? We know this one equals 180 degrees, right? We don't need to know the measure of each angle. But we know the sum of these three interior angles always equals 180 degrees. For a quadrilateral, the same thing. If the sum of these four angles add together, what is that equals? You can start from a special rectangle. You can like this. Then you know each angle that's right angle, right? Each one that's right angle. That means each one equals 90 degrees. So you have 4 90 degrees. 4 times 90 degrees, you got this one equals 360 degrees. Okay? Then for general quadrilateral, you don't have to be a rectangle. We can do this. We can like connect these two lines. Then we got two triangles, right? So we already know the sum of interior angles in a triangle, that's always equals 180 degrees. Because this one you have 180, this one 180, so therefore you got the, for general quadrilateral, the sum of their interior angles always equals 360 degrees, right? Now our question is, what is the sum of the angles in a general polygon like this? What is the sum of these 5 angles? Okay, everybody can answer this question? You know, you already know the sum of interior angles in a triangle, that's 180 degrees. The sum of interior angles in a quadrilateral, that's 360 degrees. Then my question is, what is the sum of interior angles in a pentagon? 5 sides. Okay, Rebecca, that's correct. Who else? Okay. Yeah, think that, keep that in mind, then we'll get that. So here, that's a name for the polygon with different size. 3, that's triangle. 4, that's quadrilateral. 5, that's pentagon. 6, that's hectagon. 7, that's heptagon. 8, that's octagon. 9, that's nonagon. 10, that's dectagon. 12, that's dodectron. Okay, so I think the first 1, 2, 3, 4, 5, 6. This 6 is very important. You need to know their name. Okay. Now let's say some example problems. 12. Let's say this 12. So this one, the A asks you use a protractor to find the measure of the 3 angles in each of the triangle below. You can just measure that. Then B, can you guess a statement that is always true about the sum of interior angles in a triangle? Actually, I already give you that. The sum of interior angles in a triangle always equals 180 degrees. Okay, you can get that. Now 13. This one try to help you prove that. Why the sum of interior angles in a triangle always equals 180 degrees. So here, suppose we have a triangle ABC, then pass through A, you draw a line parallel with BC, This line, suppose that's DE. Okay, this line parallel with BC. Then you have this angle will equal this angle C, right? And this angle will equals angle B. Then the sum of, because DAE is a straight line, because DAE is a straight line. So you can see here one more time, we use this straight line. This one is a straight line, right? Therefore, the angle DAE equals 180 degrees. That's a straight angle. But this angle actually equals angle DAB plus this angle plus angle BAC, also plus angle EAC, right? That's plus this angle plus this one, also plus this one. These three angles add together, you got a 180 degree. Then, because DE parallel with BC, then DAB actually equals angle B, angle ABC plus angle BAC. I just move this one down, right? I use ABC to replace DAB because these two angles, they are alternative interior angles. Then plus angle ACB. This is the same reason, because this angle equals this angle. They are alternative interior angles. Therefore, these three angles add together, that's 180 degrees. Because the sum of these three angles actually the sum of interior angles in this triangle. Therefore, this one equals 180 degrees. Right? So this is the way to prove the sum of interior angles in a triangle equals 180 degrees. Now let's see next problem. 14. The measure of one angle of a triangle is double the measure of another angle of the triangle, and 15 degrees greater than the measure of the third angle of the triangle. What is the measure of the angles of the triangle? So, say I told you first you need to try to draw a triangle. Always try to draw a triangle. Draw a diagram. So here, say the measure of one angle of triangle is double the measure of another angle. Okay, so now let's suppose this angle is x degree. And this one, that's 2x. That's double of this one. Okay? Then it's double measure of another angle of the triangle, and is 15 degrees greater than the measure of third angle. So that means we might maybe mark this one's not good. Give me a second. Probably we can do this way. Still connect this. Now let's set this angle equals 2x, and it's 15 degrees greater than the measure of third one. So this one, that's also equals 2x minus 15, right? So here you need to read this sentence carefully, okay? This one. See, they tell you, suppose we have this angle measure is double of another angle. Suppose this angle is smaller angle. This angle is twice of this one. And also they tell you this angle actually is 15 degrees greater than the measure of third one. Suppose this one is third one. They tell you this angle is 15 degrees greater than this one. So that means this third angle is 15 degrees less than this. Okay? So that means this angle equals 2x minus 15. Therefore, then you can use the sum of these three angles added together equals 180 degrees to solve this problem. You get x plus 2x, then plus 2x minus 15. This one equals 180. Okay? So then you simplify this, you get a 5x minus 15 equals 180. Then both sides plus 15, we get the 5x equals 195. Then both sides divided by 5, we get x equals 3, that's 15. Then remainder is 45 divided by 5, that's 9, right? 39 degrees. This one, that's 39 degrees. That means this one will be 78 degrees. And this one will be 63 degrees. Then you add these three together. You can say 63 plus 39 plus 78. This will be 132. Well, no. This 100. There will be 102 plus 78. That's equals 180. So that's correct. So then that means the angle that will be 39 and 63 and 78. These 3 degrees. Okay. This problem is a little bit hard. Okay, and this when you read these problems, you need to really be careful. But I think first you still need to draw this diagram. Okay. Then mark the smallest angle as x. Then the other, these two, you can just choose one of them. But sometimes, first you can choose this either one. Suppose you choose this one, then but you need to make sure they tell you the third angle actually is 15 degrees less than this one. When I draw this picture, I found this angle looks like bigger than this one, right? Then later I switch. I need to use this one as 2x as the largest angle. Then this one should be 2x minus 15, right? But if you don't want to do that, you still can just mark this one as 2x. This one should be 2x minus 15. But it looks like that's not make sense. But what you draw is not scaled. Then that still can help you understand this problem. Then you add all these three angles. You should get a 180. Then solve that, and x. You got x should equal 39 degrees. Then you can find the other two angles. Okay. So now 15. This problem introduces the type of the triangles. Then they said if a triangle have one angle equals 90 degrees, we call that triangle is a right triangle. Okay, the right triangle, that means you have one angle is right. Right, that means 90 degrees. Okay, then if a triangle we call obtuse triangle, that you have one angle is greater than 90 degrees. Okay, you have one angle should be greater than 90 degrees. If you have all angles are less than 90 degrees, we call that acute triangles, acute triangle. Okay, so here we have three questions. 1. A. Is it possible for a triangle to have more than one angle that is right or obtuse? Everybody give me answer for this. Is this one yes or no? Okay, Joyce correct. Brian is correct. A triangle is not possible, impossible, to have more than one right or obtuse triangle, right or obtuse angles. Why? If you have, suppose you have two angles, it's right angles. So that will be 90 degrees times 2, then also need to add a third angle. Because you add these two together, you already get a 180 degree. Then you still need to add another one. This one definitely greater than 180 degree. But we already know the sum of interior angles of a triangle should equals 180 degree. That will get a contradiction, right? Now, if this happened, the sum of the interior angles of triangle will greater than 180 degree. Same for obtuse angles. If you have two obtuse angles, when you add these two angles, it's already greater than 180 degrees. This will against the theorem. We already know the sum of interior angles in a triangle should equals 180 degree. So definitely this one is wrong. You cannot get a triangle has more than one right or obtuse angles. B. They ask you to explain why the acute angles in a right triangle must sum to 90 degrees. Okay, so that means in a right triangle, suppose this one is a right triangle. Okay, they ask you why this angle add this angle always equals 90 degrees. Okay, now let's see. Brian said because a right is 90 and the other is acute. Acute is same, and 180 minus 90 is 90. The acute is the same to the sum must be, yeah, that's correct. So in any right triangle, we still know the sum of these three angles equals 180 degree. Then this right angle, that's 90 degree, right? So that means sum of these two will equals 180 minus 90. So that should equals 90 degree. Sum of these two angles should equals 90 degree. Then let's say C. If the measure of two angles of a triangle have a sum equals to measure of the third angle, must the triangle should be a right triangle? Okay, so then they ask you this. If the measure of two angles of a triangle have a sum equals measure of the third one, must the triangle be a right triangle? Yes or no? Let me ask Joyce, can you explain why? You gotta know. Joyce?
I don't think so, because suppose you have one angle that is 43 degrees and another angle that is 57 degrees, and if you add those up, then the sum of those, the right angle is 100. And if there is one, and 100 is more degrees than a right triangle, so it's an obtuse angle.
But you see, if you add 43 and 50 together, you got a 100 degree, right? So 100, but 100 is not equal this 80. Right? See, this said here, the measure of the two angles of triangle have a sum equals measure of the third angle. Then they ask you this, and if this angle is right triangle. So you give this example, this 43, 57 add together, that's 100. But this 100 is not equal this third angle. They said if you have the sum of these two angles equals third angle, then they ask you if this is the right triangle. So the example you give here is not work. Okay, so then now let's see here. Brian, can you explain why you said this one yes? Brian?
I said yes because I don't know how to explain it, but like I just know.
Okay, actually we can prove this. Suppose this one's A, this one's B, this one's C. Okay, in this triangle, suppose we have angle A plus angle B equals angle C. Okay, so that's this, they tell you if the measure of the two angles, angle A and angle B, have a sum equals the measure of third angle equals C, then now let's prove actually then this angle triangle have to be a right triangle. You know why? Because we know the sum of these three interior angles should equals 180 degree, right? Because angle A plus angle B plus angle C should equals 180 degree, right? You know this. And you also have this. Now that means we use angle A plus angle B, we use angle C to replace angle A plus angle B. So we got angle C plus angle C equals 180 degree, right? See, angle C equals angle A plus angle B. So therefore, we use angle C to replace angle A plus angle B. Then we got 2 times angle C equals 180 degree. That means angle C, both sides divided by 2, got 90 degree. Right? So then we prove this angle always equals 90 degree if you have angle A plus angle B equals angle C. So therefore, this triangle always be a right triangle. So then, actually, you compare this statement with this one. The statement B told you in a right triangle, okay? Suppose angle C equals 90 degree. In a right triangle, the sum of other accurate angle always equals 90 degree, right? We already proved that. You know this one's 90 degree, the sum of these two added together should equals 180 minus 90, also equals 90 degree. But this one, it's a reverse statement. Then they said, if we have the sum of these two angles always equals the third angle, then this triangle should be a right triangle. So then you can say the statement A, that's we can suppose that's in a right triangle, then the sum of other two angles equals 90 degrees. And statement B, that if we have angle A plus angle B equals angle C, then this triangle should be a right triangle. These two statements, they are equivalent. That's actually exact same. So this one actually is a very important and special. Okay, a lot of mathematicians, they always try to looking for the equivalent statements, because that's give you exactly the same facts, but in the different ways. Okay, here statement A, that's come from this one, tell you in a right triangle, the sum of two accurate angles always equals 90 degrees. Okay, then the C tell you if you have the sum of two angles always equal the third angle, this triangle always be a right triangle. These two statements are exactly the same. They are equivalent. This is very important. Okay. So here, now let's go to next problem. 16. 16, they ask you what is the sum of the measure of interior angles of the square. You know, for a square, that's each angle we know that's equals 90 degrees, right? This each one, that's 90 degrees. This same with a rectangle. Each one is 90 degrees. So then they ask you the sum of interior angles in a square. Yeah, Joe is correct. That would be 360 degrees. That's 90 times 4, right? Now they ask you B. Draw two quadrilaterals that are not squares and measure their interior angles with a protractor. Sum the resulting measures for each quadrilateral. Notice anything interesting? Then they ask you draw any quadrilateral. Then you can use a protractor measure these four angles. Measure these four angles. Then you add all these four angles together. See what you get. Definitely you will get 360 degrees. Then they ask you make a guess. Guess in mathematician in math we call that conjecture. Conjecture. That means it's a guess. We don't know if that's correct. We have not proved that. Even if it's correct, we have not proved that yet. Before we prove that, we call that conjecture. That's the sum of interior angles of a quadrilateral equals 360 degrees. We can make this a guess, right? Then actually we can prove that. You know, where I already show you how to prove. You just connect a diagonal, then you got two triangles. Because sum of interior angles of any triangle that's equals 180 degrees. So therefore, the sum of interior angles in any quadrilateral should equal 360 degrees, right? You can use this way to prove that. Now let's see problem 17. Say this one, our goal in this problem is to find the value of x. We try to find the angle x, this one. So everybody, can you do this? So first, A, find the measure of interior angles of triangle ABD. Okay, first can you find this angle? Can you find this one? This one, that's very easy because this is a right angle. Sum of these two accurate angles should equals 90 degrees. So this one should equals 47 degrees, right? This is 90, this is 43. So B, find the measure of interior angles of B, C, D, E. Then they ask you find the measure of interior angles of B, C, E, D. So we know this, that's 90 degrees. This one's 98, so that means this one, that will be 82, right? 82 degrees. Because this one add this one should equals 180 degrees. This should be 82. Now this one also based on the straight line, ADE, that straight line, they will form a straight angle here. This one should equals 137 degrees. Then you can use quadrilateral. The sum of interior angles in a quadrilateral equals 360 degrees. Find this one. So we can do 360 degrees minus 90 degrees plus 82 degrees plus 137 degrees. Then you should get this angle. After you get this angle is opposite of this angle. So then that means x should equal this. So then now let's do, if we add these two together, that's 219, right? Then plus 90, add together, that should be 309. So that means we should get 51 degrees, right? So x equals 51 degrees, right? So Joyce is correct. Eric is correct. Okay, that's 51 degrees. So you can say in this problem to find the x, actually here we use the sum of any quadrilateral should equals, their interior angle should equal 360. Then we find the other three angles in this quadrilateral. Then we minus these three angles from 360 degrees, then get this angle. That's 51. Okay. Now let's go to 18. 18 is A. What is the sum of interior angles of a pentagon? Pentagon, we already know that, right? Pentagon. So how we can find the measure of, say, let's say this shape, 1, 2, 3, 4, 5. This is a pentagon. You know, I have already told you the sum of a pentagon that should equals 540. So you can prove this by draw the two diagonals here. Then you got the three triangles, right? Suppose this one I mark here. This one's A, this one's B, this one's C, D, E, right? Then you can get the three triangles ABC, ACD, and ADE. The sum of interior angles of any of these three triangles should equals 180 degrees, 180 degrees, and 180 degrees. So therefore, 180 times 3, you got a 540 degrees. So this one, that means for pentagon, the sum of the interior angles of a pentagon equals 540 degrees. So then they ask you, what is sum of the interior angles for hexagon? Hexagon, the shape is like this. You can draw like this, right? 1, 2, 3, 4, 5, 6. To find this, if you try to find that, you can also use, you connect this side, and this side. Then you get 4 triangles. So that means the sum of interior angles in a hexagon, that will equals 180 degrees times 4. You get 720 degrees, right? Now, B, find the formula for the sum of the interior angles of polygon with n sides. That should equals 180 times n minus 2 terces. You can say when n equals 3, 3 minus 2, that's 1, times 180, that's for triangle. For quadrilateral, 4 minus 2, 2 times 180, 360 degrees. For pentagon, that's 5. 5 minus 2 is 3. 3 times 180, that's 540. For hexagon, 6. 6 minus 2, that's 4. 4 times 180, that's 720. Okay? Then that means this one is correct. Okay? Use this formula, you can calculate any polygon, the sum of their interior angles. Now, let's say for a regular polygon, that means all sides are equal and all angles are same. Okay? That's called a regular polygon. Then a regular polygon in which all of the sides have the same length and all their angles have the same measure, which is the measure of each interior angle of regular polygon of a regular octagon. So a regular pentagon, they ask you what is the measure of each interior angles of regular pentagon. Can you help me calculate that? You can use 540, that's the sum of all angles, all interior angles in a pentagon, then divide by 5. Then this one give you the measure of each angles in a regular pentagon, that's 180 degrees, right? Then they ask you what is the measure in the regular 8 sides octagon. Octagon, then you need to use 180, then 8 minus 2 times 180 give you the measure of sum of interior angles in a octagon, then divide by 8. So then you can do the 180 times 6 divided by 8. So we can simplify this one 3, this 4. So this 45. So that's 135 degrees. Okay, in a octagon, regular octagon. Okay, you can use this way to calculate each angle, measure of each angle in a regular polygon. Now 19. This one, they give you a pentagon. This is a pentagon. Pentagon in the diagram below is a regular. See, this one is a regular. Then they ask you what is the measure of this angle. They ask you what is this x equals. Ask this. Okay, can everybody do that? You know, we already get for a regular pentagon, each angle should be 180 degree, 108 degree. So that means this angle will equal 72 degree. And this angle also equals 72 degree because this one equals 180 degree. Then in this triangle, sum of these three angles should equals 180 degree. So 72 plus 72, that's 144. So that means this one equals 36 degree, right? This one equals 36 because 144 plus 36. So that means x equals 144 degree. Okay, x equals 144 degree. So you can see to solve the geometry problem, you need to use logic. Start from the beginning. They give you this is a regular pentagon. So we know each angle in a regular pentagon should be 108 because that's 540 divided by 5. This gives you 180 degree. Then you can get this exterior angle should equal 72 degree because these two angles add together should give you 180 degree. Then this one same. You also get this one equals 72 degree. Then the sum of these three angles should equals 180. So that means this angle equals 180 minus 144, that's 36 degree. Therefore, this angle should equals 180 minus 36 degree. So that's equals 144. So actually, another way you can calculate this angle equals sum of these two. Okay, that's called the exterior angle theorem. In a triangle, any exterior angle equals the sum of the other two angles that not adjacent to this angle. So that means this exterior angle always equals the sum of these two angles, not adjacent to this angle. Okay? Now let's see next one. 20. 20 actually tell us a very important conclusion. See here, when we extended the three sides of a triangle past the vertices, we form exterior angles. So that means, say, we have a triangle ABC here, right? If you extended CA, make this one longer, then you form an angle here. This one. Suppose this one called X. Then you extend AB. Then you form an angle here, we call it Y. Then you extend it BC, you form an angle here called Z. Then they ask you, what is A plus B plus C? The sum of interior angles in this triangle, definitely we know this one equals 180 degree, right? Then what is A plus X? A plus X, this also equals 180 degree because CA, that's a straight line. Then they form a straight angle here. So that means A plus X equals 180 degree. Then they ask you, what is X plus Y plus Z? Everybody, can you give me this answer? X plus Y plus Z. So from this one, you can get X, yeah, Eric's correct, Joyce correct. You can get X equals 180 degree minus 8, right? Then from here you can get a y also equals 180 degree minus b. And from here you can get a z equals 180 degree minus c. Therefore, x plus y plus z will equals 180 minus a plus 180 minus b plus 180 minus c. That's give you 540 degree minus a plus b plus c. So that's equals 540 minus 180 degree. This gives you 360 degree. Okay, time is up. We can stop here. The homework, that will be exercise problem behind each section we learn here. So we can stop here. See you next time.